Hey, there, we got cut off just a little bit at the end there, but it was equal to C15, which is D bar, divided by parentheses, don't forget your parentheses, SD divided by the square root of this number, which is your N, and then close your parentheses. All right, so there's our test statistic. Now we need our critical values. So these are going to be T dot inverse dot 2T. And then the probability is equal to alpha right there. Degrees of freedom is 12, take away 1. So why is it alpha, not alpha over 2? Well, it's because you do the dot 2t thing. It actually knows to cut alpha in half for you. Nice, huh? And then the other one would be the negative of that, because that'll get you your lower and your upper, right? So you need two critical values because this is a two-tailed test. Now, what if you have old school Excel? Well, it's actually the same thing. It's T inverse and then 0.01. Degrees of freedom is 12, take away 1. And I know what you're thinking. You're thinking, well, that seems easier. Yes, it is, except for one-tailed tests. Two-tailed tests, they're kind of equal to each other in difficulty. But one-tailed tests is much easier with the new functions than the old functions. We'll get to those later in other videos. All right, now the p-value is going to be equal to t.dis.2t because it's a two-tailed test. X was 0.85. Degrees of freedom is 12, take away 1. Close parentheses. Enter. There we go. Now, old school Excel would be T-dist. Again, 0.85. Degrees of freedom is 12, take away 1. And you just tell it 2 for two-tailed. Enter. Now, I don't know about you, but this is kind of funky formulas, so I love to double check myself. And I'm going to with StatCrunch. So let me go here, and I go to, notice because this is one that's in the book, it's right here. If it wasn't, I could just type it in. And I go to Stat, T Statistics. This is paired data, so I'm going to click paired. And it says, hey, sample 1 is in column A, sample 2 is in column B. Next. Oop, back just for a second. You have the option to save your differences, by the way. Might be useful if you want to have that column or not. I mean, it's up to you. And then it's saying, what's your mean difference? 0. It's a not equal to test. Next. I don't care about that. Calculate. And see, there you go. Your T statistic, see right there, 0.85. And the p-value is 0.412, and then you see it typed in all the differences for us right there, just like Excel did. So I could always copy and then go back to my Excel and paste these values in. See? Hold on. There they are. All right, so I've got all those numbers in, so I can see it through StatCrunch or I can see it through this. Either way, I am going to not reject the null hypothesis. So let's write that out. Do not reject H0. And you can think of it for two reasons. You do not reject H0 in the classical way because your test statistic T0, which is equal to 0.8517, is not in the critical region. In other words, it's not lower than negative 3.105 or higher than positive 3.105. The p-value way, which is much simpler, you're doing it because p, which is equal to 0.4125, is not less than alpha, which was equal to 0.01. All right, awesome. We are done with the hypothesis test. Next time we will work on the confidence interval, constructing the 99% confidence interval.